Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a right circular cylinder having base diameter 50 mm and axis height as 70 mm. Now this right circular cylinder, it is resting on its base onto the horizontal plane and its axis happens to be perpendicular to the horizontal plane. Now this cylinder has been cut by a square hole in such a way that the center of the square hole, it is going to coincide with the center of the axis of this particular cylinder, and the axis of the square hole happens to be perpendicular to the vertical plane over here, and the edge of the square hole happens to be 25 mm, and the two edges of the square hole, they happen to be equally inclined with respect to the horizontal plane. So with this information, we are required to obtain the projections of the right circular cylinder, and we are also required to obtain the development of the lateral surface of this truncated cylinder over here. So now let us proceed with evaluation of orthographic projections of this right circular cylinder. So as the observer is going to look at this right circular cylinder from the top, now we are going to view the circular projections of the cylinder into the top view projections obtained onto the horizontal plane, and these circular projections will be drawn below the XY reference line. Here we have got the diameter of the cylinder equal to 50 mm, and we have plotted all the 12 points corresponding to the base of the cylinder using the red color on the inner side of the circular projection, while the 12 points of the top face of the circular cylinder have been marked over here with black color, and these points, they have been marked outside the circular top view projection over here, and the axis of the cylinder O and O1. So these 2 points we have marked into the top view projection. Point O refers to the axis point corresponding to the top face of the cylinder, while point O1, it is the axis point at the base of the cylinder over here. So now, having obtained the top view projections of the cylinder, now we are required to obtain the front view projections corresponding to this right circular cylinder. So we know that the axis height of the cylinder happens to be 70 mm. So using the axis height of 70 mm, we have been able to obtain the projections of the cylinder into the front view elevation view over here. And we have also marked all the vertical generators of the cylinder originating from the 12 points of the base over here, right? So this way we can see the 12 points of the top face we have been able to mark at a height of 70 mm above the XY reference line, while the 12 points corresponding to the base we have marked onto the XY reference line over here, and the axis points O dash and O1 dash corresponding to this cylinder we have also evaluated into the front view projections over here. Point O dash happens to be the axis point corresponding to the top face of the cylinder, while O1 dash, it is the axis point which is lying onto the base or onto the XY reference line over here. So now we know that this square hole, it is going to pass through the midpoint of the axis. So we know the axis O dash O1 dash. So the midpoint will be lying at a distance of 35 mm from the base of the cylinder. So we have marked a point which is going to correspond to the center point of the axis over here at a distance of 35 mm from the base. Now using the symmetry, we have drawn projections of the square hole whose axis is going to coincide with the midpoint of the axis of the cylinder over here. The edge length corresponding to the square hole happens to be 25 millimeter over here. So now we can mark the points corresponding to the square hole as A dash, B dash, C dash and D dash over here. Now this square hole is going to pass through both the front face of the cylinder as well as the rear face of the cylinder. So now we can see that this square hole, it is going to intersect with the vertical generators 3 dash and 3-1 dash, 11 dash and 11-1 dash. Similarly, this square hole is going to intersect with vertical generators 5 dash, 5-1 dash, 9 dash, 9-1 dash and 4 dash, 4-1 dash and 10 dash and 10-1 dash over here. So the 6 vertical generators of this cylinder, they are going to be intersected by this square hole. But these corners, that is the corner points A dash and C dash, they are not going to intersect with any of the vertical generators of the cylinder over here. So now what we can do, from point A dash, we have drawn a vertical projector line and let us evaluate the location of the point A dash corresponding to the points 2 and 3 of the circumference of the cylinder on the rear side. Similarly, we want to evaluate the location of the point A dash corresponding to the circumference points 12 and 11 which are lying onto the front side of the cylinder. So we obtain that point A dash location can be obtained into the circumference of the cylinder at points A into the rear side between points 2 and 3. Similarly, point A can also be located onto the front side between the circumference points 11 and 12 over here. Similarly, corresponding to the point C dash, now we observe that if we draw a perpendicular projector from the point C dash, now the point of intersection of this vertical projector with the circumference of the cylinder on the rear side between the circumference points 5 and 6, it will provide us with the location of point C in the top view projections. Similarly, this vertical projector through C dash, it is going to intersect between the circumference points 8 and 9 onto the front side of the cylinder over here. So again, another point C will be located over here. And another thing we can observe that these two corner points corresponding to the square hole B dash and D dash, so they are going to coincide with each other when we are going to look at these 2 points from the top view projection. So we are going to obtain the coincidence of these 2 points of intersections, that is corresponding to B dash and D dash, into the top view projections corresponding to the vertical generator 441 and 1010-1 over here. So we can see in the top view projections point 441 B and D, they will be coinciding onto the rear side of this particular cylinder, and the points 10-1 B and D, they are also going to coincide into the front side or the front face of this particular cylinder. So this way we have been able to obtain that the 6 points of intersections, they are available with the vertical generators of the cylinder corresponding to points A dash and C dash. We have been able to obtain their locations alongside the circumference points 2, 3, 11, 12, 8, 9 and 5, 6 points over here. So now let us obtain the development of the untruncated or uncut right circular cylinder over here. So we all know that we are going to make use of parallel line development method in order to obtain the development of the right circular cylinder. So from the top face we have drawn a horizontal projector line, from the bottom face or the base of the cylinder again we have drawn a horizontal projector line. So the distance between these two horizontal projector lines, it has provided us with the true length of the height of this particular right cylinder over here, which happens to be 70 millimeter. And now we are going to measure the distance between these sector points over here. So as we have seen that we have divided the circle into 12 equal parts, so that each one of these sectors, they are going to measure 30 degree each over here. So now once we measure distance between the points 1 and 2, 2 and 3 and so on, so we evaluate that distance between the successive points, it will be equal to the distance between the points 1 and 2 over here. So the 12 segments corresponding to each one of these sectors we are going to obtain over here. So we are going to start the development of this cylinder from the point number 1 over here. So as we move from point number 1, so we see that 12 points we have been able to mark over here, and then the last point will be the starting point. So once we mark these 13 points, so the 12 sectors we have been able to open up into the lateral surface development view of the uncut right circular cylinder over here. So now onto the surface of the square hole which we have to obtain over here, the points of intersection, they are not symmetrically located over here. The first point of intersection lies at A dash, then the second point of intersection lies onto the vertical generators 3 dash and 11 dash over here. Then there is a huge distance from this point of intersection till you reach the point number B over here. So because we do not have any point of intersection between this point and the point B dash, which is lying onto 4 dash and 10 dash over here. Similarly, as we are going to proceed from B dash to C dash, again we see that one point of intersection is C dash. Another point of intersection is lying onto vertical generators 5 dash, 5 1 dash and 9 dash and 9 1 dash. But then there is large distance between this point of intersection and point B dash over here. So now what we can do, between these 2 points and between these 2 points over here, so 2 points arbitrarily we can assume over here, so that we should be able to obtain more number of points of intersection, so that the accurate construction of the development of the square hole can be obtained corresponding to the rear face and corresponding to the front face for the cut section view into the lateral surface development over here. So now we can see that between this point and B dash, so one more point, approximately the midpoint of this distance we have chosen over here. So this point, the moment we mark this point, so we have labeled this point as P1 dash. So this artificial point P1 dash has been introduced between A dash, B dash, and similarly between A dash, D dash also, so that 2 points P1 dash, so symmetrically they have been located between the surfaces A dash, B dash and A dash, D dash over here. So once we obtain these 2 points as P1 dash, now the vertical projector drawn through P1 dash into the top view projections, it will facilitate us to locate the location of these 2 points onto the circumference. So we can check on the rear side, this point P1, it will be lying between the circumference points 3 and 4, whereas onto the front face, this point P1 dash, it will be located as point P1 between the circumference points 10 and 11 over here. Similarly, one more point we have chosen over here. Approximately this will be the midpoint of this distance of B dash up to the point of intersection, which is going to be obtained by virtue of point 5 dash and 9 dash over here into the square hole edge over here. So now once we obtain the second point, so we have named this point as P2 dash. So we have got P2 dash located onto the edge B dash C dash. We have located the point P2 dash onto the edge C dash D dash over here, so that now more number of points of intersection we have been able to obtain over here. So having obtained these 2 points of intersections which are not lying onto the vertical generator of this right circular cylinder, now we need to obtain the location of these points, that is P2, into the top view projections onto the circumference points over here. So we see that if we draw a vertical projector through P2 dash, so now on the top view, P2 point is going to lie between the circumference points 4 and 5 on the rear side of the cylinder, and onto the front side of the cylinder, P2 point will be lying between the circumference points 9 and 10 onto the front side of the cylinder. So now we can see we have been able to obtain a reasonably large number of points which are going to yield a better geometric construction corresponding to the square hole in the rear side and the front side respectively over here into the lateral surface development view. So now 4 points we have introduced over here. 2 points corresponding to points A and C, 2 additional points corresponding to P1 dash and P2 dash over here. So let us obtain these 4 vertical projectors into the lateral surface development view over here. So now we can check point A. So where does point A lie? Point A lies between the circumference points 2 and 3 over here. So we can measure the distance between point 2 and point A as we are going to move from point 2 to point 3 over here. So as we move from point 2 to 3, point A will be lying over here. So once we measure this distance from 2 to 3, we can mark the same distance and a vertical projector with blue color we have drawn over here corresponding to A dash and C dash. So corresponding to point A onto the rear side as we move from point 2 to 3. So this distance has provided us with the vertical projector corresponding to the point A over here, right? Now let us locate the second point over here. The second point over here happens to be point P1. So we know that on the rear side, point P1 will lie between the points 3 and 4 over here. So as we move along the circumference from 3 to 4, at this distance from point 3, point P1 will be located. So now from 3 point, as we move towards the point number 4, so at the same distance, a black vertical projector has been drawn over here. So corresponding to points P1 and P2, we are using black color projectors. Corresponding to corner points A and C, we are going to use the blue color projectors over here. So point A and P1, they have been located corresponding to the rear face of this particular cylinder over here. Now the next point which is available with us onto the rear side, it is point number P2. So we can check point P2. It lies between the circumference points 4 and 5 over here. So we can measure the distance from point 5 as we are going to move towards point 4. It will be this distance, so that P2 vertical generator can be located over here. So from point 5, as we move towards point 4, by marking the same distance over here, the vertical generator, that is the black generator corresponding to the point P2, has been located over here, corresponding to the rear face of this particular circular cylinder. Now the next point happens to be point C on the rear side. So we know that point C on the rear side lies between circumference points 5 and 6. So again, we can measure distance from point 6 to point C, mark the same distance from point 6 to point C over here, and a blue vertical generator corresponding to the point C we have been able to locate. So the 4 additional vertical generators, 2 blue ones corresponding to the points A and C, 2 black ones corresponding to the points P1 and P2 we have been able to locate. Now, same procedure we have to follow to identify and locate these 4 vertical generators corresponding to the front face of this particular development surface over here. Let us obtain point C on the front face. So we know that point C on the front face will be located between the circumference points 8 and 9. So as we move by this distance alongside the circumference, we'll be able to locate point C. So as we are moving from point 8 to 9, measure this distance, plot the same distance over here. So again a vertical blue generator we will be able to obtain corresponding to the corner point C over here. Next point available with us is P2 over here. So we know that point P2, it lies between the circumference points 9 and 10. So once we measure the distance from point 9 to point P2, as we move along point 9 to point 10 along the circumference, so we'll be able to locate point P2 over here. Next point which is available with us onto the front face happens to be P1. So we know that P1 lies between points 10 and 11, right? So as we move from point 10 towards 11, so we measure this distance. Accordingly, the location of the point P1 we can measure. So as we move from point 10 to 11, now we'll mark the same distance over here, and the black generator corresponding to the point P1 will be located over here. And the last point, it is point A. So we know that point A, that is the blue generator, will be able to obtain between the circumference points 11 and 12. So once we measure the distance of point 11 to A along the circumference and mark the same distance over here, we'll be able to obtain the blue generator corresponding to the point A over here. So this way, now we can see that extensively large number of points we have been able to obtain in the lateral surface development view corresponding to the rear square hole, corresponding to the front face real hole. So now the corresponding points of intersection now we are going to obtain to locate different points of intersection of the square hole and this right cylinder into the lateral surface development view over here. So now let us obtain each one of these points of intersection into the development surface view over here. We also know that the points B and D, they will be coinciding with vertical generators 4, 4, 1 and 10, 10, 1 over here. We have already checked this out in the top view projections as well. 4 and 4, 1, B and D, they have coincided with each other. Similarly 10 and 10, 1 and B and D, they have coincided with each other. So the projectors corresponding to the points B and D and 4, 4, 1 and 10, 10, 1, they have coincided with each other. That is onto these two vertical projectors, that is 4, 4, 1 and 10, 10, 1. So the 2 points of intersection corresponding to the points B and D, they will be located over here and over here as well. Now we are going to evaluate the location of different points of intersection into the development surface area over here. So now through all of these points of intersections, we have obtained the horizontal projectors such that these horizontal projectors, wherever they will be intersecting with their corresponding vertical projector locations, so the different points of intersection corresponding to the intersection of the square hole with the circular cylinder will be obtained over here. So let us obtain each one of these points one by one. So the first point of intersection happens to be point A dash. So from point A dash, we have drawn a horizontal projector line. So wherever this horizontal projector line, it is going to intersect with the blue color vertical projector line, which is going to emerge from point A. So the point A will be obtained corresponding to the front face and the rear face location of the square hole into the development area over here. Next 2 points of intersection, they happen to be lying corresponding to the vertical generators 3 dash, 3 1 dash and 11 dash, 11 1 dash. That is onto these 2 vertical generators. Please check the vertical generator 3 3 1 and onto vertical generator 11, 11, 1. So onto these two generators. Now let us evaluate where do we obtain the intersection of the points of intersection corresponding to the horizontal projectors drawn from these 2 points. So once we draw horizontal projector number 1, once we draw horizontal projector number 2 over here, so wherever these two horizontal projectors, they will be intersecting with vertical generators 3, 3, 1 and 11, 11, 1 over here. So the 2 points of intersection onto the rear face and 2 points of intersection onto the front face, they have been obtained over here. Now the next 2 points of intersection, they are corresponding to artificial point which we have introduced, that is the black color projection line corresponding to the point P1. So now we can check corresponding to these two additional points P1 dash and P1 dash. So 2 horizontal projectors we have drawn. So this horizontal projector 1 and this horizontal projector, this is the second horizontal projector. So wherever these 2 horizontal projectors, they are going to intersect with vertical generators through the points P1 whose location has been identified through the distances of these 2 points alongside the circumference on the rear side and on the front side. So P1 points, they have already been located. So onto these 2 black vertical generators corresponding to the point P1, wherever they are going to intersect with 2 horizontal generators drawn through these 2 points. So another couple of points onto the rear face, another couple of points onto the front face, they have been identified over here. So now 2 more points in the front, 2 more points of intersection onto the rear face, they have been obtained into the developed surface area. Now the next 2 points, they are B and D. So from B dash and D dash. So we have got these extreme horizontal projectors over here. Horizontal projector number 1 through B dash, horizontal projector number 2 through the point D dash over here. So wherever these 2 extreme horizontal projectors, they are going to intersect with the vertical projectors 4, 4, 1 and 10, 10, 1 over here. So another 4 points we are going to obtain. These are 2 extreme points which are available corresponding to the points B and D on the rear face of the cylinder. Again 2 points of intersection B and D, they are obtained corresponding to these 2 points B dash and D dash onto the vertical generator 10, 10, 1 over here. So this way 2 points on the front face, 2 points of intersection on the rear face, they have been identified over here. Now the next 2 points, they are available with us corresponding to artificial point P2 dash which we had marked over here into the front view projections over here. So now once we draw these 2 horizontal projectors through the points P2 dash over here into the development surface area, wherever these 2 horizontal projectors, this one and this one, they are going to intersect with vertical projectors drawn through the point P2 in the rear face and through the point P2 into the front face. So we are going to obtain 2 points of intersection onto the rear surface, 2 points of intersection they have been obtained on the vertical generator through P2 over here onto the front side of this particular cylinder over here. Next 2 points, they are corresponding to the generators 5 dash, 5 1 dash and 9 dash and 9 1 dash. So now through these 2 points of intersection which were obtained onto the vertical generators 5 dash, 5 1 dash, 9 dash, 9 1 dash. So if we draw the horizontal projector number 1 and we draw horizontal projector number 2 over here. So wherever these 2 horizontal projectors, they are going to intersect with vertical generators 5 5 1, 2 points of intersection they will be obtained. Wherever these 2 horizontal projectors which are drawn through these 2 points, they will be intersecting with the vertical generator 991. So another couple of points of intersection, they have been obtained corresponding to the square hole onto the front side surface of this cylinder over here. And finally the last point is C dash. So now corresponding to point C dash, we have drawn a horizontal projector line, that is the central one. Wherever this horizontal projector line, it is going to intersect with vertical blue color projection lines corresponding to the point C over here. So the two vertical projectors blue color, we have identified one in the rear face, one in the front face over here. So the intersection of this horizontal projector with these two blue color vertical projectors emerging from the point C over here. So they will provide us with the location of the point C into the rear face and the front face respectively. So now all the points of intersection of the square hole with the right circular cylinder, they have been obtained into the rear face and into the front face as well. So we can join all of these points of intersection onto the rear face and onto the front face. So now we will see that this is the development of the square hole which is going to be obtained onto the rear side of the developed surface. This is the development of the square hole which is obtained onto the front side of this circular cylinder surface over here. Now we can join the boundary over here. So this way we'll be able to obtain the development of a right circular cylinder which has been cut by a square hole such that the center of symmetry or the axis of this square hole which is perpendicular to the vertical plane. So this center of symmetry of the square hole, it coincides with the midpoint of the axis of the cylinder over here, and the two edges of the square hole, they happen to be equally inclined with respect to the horizontal plane. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.